Okay, YouTube, in this video we're going to focus on how we can quickly sketch transformations of exponential functions. And so in this previous set of videos we learned that exponential functions are of the form y equals b to the x, where b, we said b is not allowed to be 0. It's not allowed to be negative, as a matter of fact. Let's just put it this way. We say b is greater than 0 and the base is not allowed to be 1. But with that being said, we know that all exponential function graphs, let me click back on my pen tool here. All exponential functions graphs go through the point 0, 1, and they either grow or they decay from left to right. And they look something like this. And they all have asymptotes on the y-axis. Now I would say that it is only true that they do this if they are of the form y equals b over x. So what we're going to see in this video, we're going to see instances like this one up here on the right. It says use the graph of f of x equals 3 to the power of x to graph g of x, which is 3 to the x minus 1. And so what I want you to see is essentially when you write g of x equals 3 to the x minus 1, that's really the same thing as our parent function, but we're going to have some sort of transformation here. So what we're going to see more generally speaking now is graphs that look like this. Instead of b to the x, we're going to have a times b to the x minus h, all in parentheses, plus k. And I want to write a few notes about this. Starting with this, we'd say h is horizontal translation. Horizontal translation. We've seen this before. And we say k is vertical translation. Now, one thing to keep in mind with horizontal translation is that it is a liar. I say a liar that is, it looks like it's the opposite here, okay? And as far as a is concerned, we say if a is, well, let's generalize it this way. If a is positive, then we have a function that's going to be above the asymptote here. If a is negative, then all of a sudden we're looking at a situation where we have reflection. So in terms of vertical translation and horizontal translation, you can see that for vertical translation, we say that g of x is just some b of x, either plus c or minus c on the outside. For horizontal translation, you notice this constant that they're adding on or subtracting off, they're adding it onto or subtracting it off the x there. So that's what we're calling our h value here, is what they're calling our c value here. But that would shift it left and right. Now you notice that reflections, we say if you were to put a negative in front of your base, okay, that would be the same thing here, by the way, as if I wrote negative g of x equals positive b to the x. So what I would end up with here is a situation where really what I did was I made my y values negative. What that's going to do is going to reflect it over your x-axis. So a negative out in front means our graph is going to reflect over the x-axis. So instead of opening that way, maybe it opens this way. And if we put a negative in front of the x, it reflects over the y-axis, okay? So last but not least, if we have a value that we're multiplying our base by, that's kind of like our a value out front here. They're using a c value out in front, but I'm using a. We say that we get vertical stretch for any a value bigger than 1, or vertical shrink for any a value that is between and not including 0 and 1. And then if we multiply our x values by a constant, then we're going to get horizontal stretch and shrink, which we're often not going to worry about with these graphs. So what I want to show you really quickly here is this. If you want to graph g of x equals 3 to the x minus 1, what we're going to do is we're going to graph the parent function. And what I mean by the parent function is the function that looks like this, where the a value is specifically 1, and our h and k values are specifically 0. So if I were to set a equal to 1 and our h and k equal to 0, I would say then my new function here, f of x, the parent function, would just be 3 to the power of x. And so what I want to say about 3 to the power of x is this. It's really, really easy to graph. We'd say it has a horizontal asymptote at y equals 0, and it goes through the point 0, 1. Now I need to find 2 more points on this parent function, and so 0, 1 on there. I'll plug in 1. I get 3 to the 1 is 3, and 3 to the negative 1 is 1/3. 1/3. So I know that if 1/3 is the height here and it's at 1,3 here, we'd say here's the graph of our parent function. So essentially what we're going to do in order to graph this function right here, what I notice is that our h value is equal to 1. So it's going to shift everything right 1 unit. So I'm going to switch my color here. Let's go over to like a green here. And basically what we're going to do is we're going to take all the points on this original graph, 0, 1, and say 0, 1, and we have the point 1, 3. We're going to shift them all right 1. And also negative 1 and 1/3. So this would be here now, right 1 here. This would be here, right 1, and this would shift right 1. And we would get this new function that essentially would be the original function but shifted right 1. So in terms of the domain of the new function here, we say, well, the domain of all exponential functions is all real numbers. And the range here, the range of both of these, as a matter of fact, is 0 up to infinity, and not including 0 because we never reach a height of 0. I just want to try this again one more time. We say if an exponential function, though, is translated upward or downward, the horizontal asymptote is shifted by the amount of the vertical shift. So again, if I said let's go graph g of x equals 2 to the x, that plus 1. Really what I do is I graph the parent first. Remember, the parent means take away the h and the k and the x, or sorry, the h, the k, the a, and we'll just write what's left. So the parent function here would just be 2 to the x. So again, 2 to the x, I'll graph this in that green color that I just used to write the function in. We say has an asymptote of y equals 0 and goes through 0, 1. Now in terms of what are some other points that I would have on this graph, well 0, 1 is one of them. 2 to the first power, that would be 2, and 2 to the negative 1 power, that would be a half. So it would be a half here, we'd say 2 here, and here is our parent function. So this is our parent function. This graph here, because our k value equals 1, it's going to shift up 1 unit. So the important thing here is this. What this mentioned up here was that the asymptote also has to shift up 1 unit. So our new asymptote is at y equals 1. Instead of 0, 1, it'll be at 0, 2, it'll shift up 1. Instead of 1, 2, it'll be at 1, 3. And instead of negative 1 1/2, it'll be negative 1, 1 1/2, because everybody shifted up 1. Whoops. Let me get a better curve here. We'd say here is our exponential function. Looks like our other exponential function, but its domain, when we talk about the domain, of course, it's all real numbers. The range, however, would be all y values greater than the asymptote, which is at 1. So that's how we can quickly sketch functions just by sketching the parent function first and then transforming it. Cheers.